sentences smashed together into one, right?
Using and or because, right?
And, but,
Conjunction with
yeah,
a
some sort of
a comma or a semicolon.
Yeah, conjunction, right?
In clauses.
Well, a compound inequality is the same thing as a compound sentence, only instead of sentences, we're cramming two inequalities together. So this is going to be two, it would help if I was using the pen, two inequalities okay. And in math, we only have two conjunctions. We have and or. Okay. Now an intersection is what happens when we have an and. And in an intersection, the inequalities overlap. If you think about it, an intersection in a road is where the two roads connect, right? And the intersection is basically that square that's made by the two roads. Well, an intersection in math and inequalities is the part of the two inequalities that overlap. And they're joined with the word and. And so we have, here's the most basic, simple intersection I can give you. I just give you two inequalities, and they have the word and in between them. And here's how that looks. If I graph x is greater than 3, that's this part right here. If I graph x is less than 7, that's this part right here. If I graph the conjunction of x is greater than 3 and x is less than 7, what I need to graph is the place where they would overlap. So if I put these two graphs on top of each other, they're going to overlap here. Do you see that? Because there's no graph past the 7 on this one, and there's no graph before the 3 on the top one. So to graph the overlap, oh. I'm going to have an open circle at 3, an open circle at 7. At 7. And the part that overlapped is what happens between the two. This is an and.
Is it recording?
Yes.
It doesn't have the green thing.
Oh, it's recording the whole thing.
Oh, I just didn't
No, it's recording. I guess I didn't select the window, so I guess it's recording the whole page. So, this is also an and. So it's also going to be an intersection. So with the and intersection, you can have two ways. It can either have two inequalities with the word and in between them, or it can be written as a compound inequality in one part. Now, there are two ways to graph or to solve this, and I will show you both so that you can use the one that makes the most sense to you. Okay? Method 1 is to keep it in one sentence. Okay, and what you do is, you know, when you're solving a regular inequality or a regular equation and you say add 3 to both sides? Well, because this is a compound, we don't have just 2 sides, we have 3.
So you add it to all three?
So we have to add it to all 3. So when I add 3 here, I'm also going to add it here and here. So whatever I do on a compound inequality, I've got 3 sides, the right, the left, and the middle. So I have to do it to all 3 parts. So then I have 1 less than or equal to x less than 4. The nice thing about keeping the inequality together in this manner, this shows you how it graphs. I have a 1, I have a 4. This is giving me a solid dot. This will give me an open dot, and the x is in between the two. So you shade that way. So that's kind of nice because it tells you exactly where to shade. But if that's confusing and you don't want to do 3 parts, you can break it into 2 sentences. So the first sentence is -2 is less than or equal to x minus 3. The second sentence is x minus 3 is less than 4. Then you'll solve each of these separately. Wow, guys. Nobody caught this. 4 plus 3.
I was gonna say that's 7, but I was just reading.
Oh, no, yeah, please, 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 when I do silly things like that, tell me. It doesn't change the graph or anything. It just changes that that should have been a 7 instead of a 4. These things happen. Call me out on them. I'll give you extra credit. Okay, now I have 2 separate statements, right? I know I have a 1 and I know I have a 7, and then I just need to figure out where the shading happens. Okay, so here's how I would do this. 1 is going to be a solid circle. And I don't like the way this is written, so I usually flip them. X is greater than or equal to 1, and so that is going to be this direction. I'm not going to shade it yet, I'm going to indicate that it's going to shade on this side. And then I have an open circle on the 7, and x is less than that, which is going to be this direction, which means I'm going to overlap it in the middle because the arrows point at each other. And so I'll shade that in. And in between, because we have 2 different y minus 3, y minus 2, it's not the same anything, so we graph or solve each of them separately. So I get y is greater than or equal to -8, plus 2 plus 2y is less than or equal to +10. To graph this, I'm going to have -8, I'm going to have a 0, I'm going to have a +10. Greater than or equal is a solid line, and greater than goes that direction. Less than or equal to is a solid dot, and less than goes that direction. My arrows are pointing at each other, so I'm shading in the middle. The reason I'm showing you the arrows is so that if you forget that and shades in the middle, you can still shade it properly. And will always shade in the middle, but if you forget that that's an intersection and so it'll shade in the middle, you can use the arrow idea so you shade it in the right spot. Okay, so let's talk unions.
Yeah, it was really expensive.
Okay, a union occurs when you have the word or. Okay, and is an intersection. It's only the parts that overlap. Well, okay, if you think about a union in the world, like unions occur when like states get together and form a country. We have a union. Or when two people get married, that's a union. Unions unite things, put them together. So unions are like a combination, combining. Did I spell that right? Hold on. Combining both graphs into one. Okay, so we're going to unite the graphs and make them one. Okay, so the way a union works, I've got x is greater than 2 or x is less than -1. Well, x is greater than 2. 0, I have, make it closer. I have 2, x is greater than that, comes out here. Right, greater than goes that way. And I have x is less than -1. 0 will stay in the same spot. And here's -1. And less than goes this way, so I shade all of this. And if I were to ask you for an intersection, an and, there would be no solution, correct? Because there's nothing overlapping. But because this is a union, what we get is a combination of the two. And you essentially you graph both graphs on the same graph.
Your ring's really shiny and gold.
This one?
Makes a rainbow.
Better?
Wasn't clear.
Well, it's got that.
Stud.
Yeah. Okay, so with an or, you take both pictures and we put them together and make one. With an and, you only take the part that overlaps. Alright, so the human ear can only detect sounds between the frequencies of 20,000 hertz and 20 hertz and 20,000 hertz.
We can't hear anything louder than that?
We can't hear anything lower than 20 or higher than 20,000.
Because it'll destroy our eardrums?
No, we just can't hear it.
Oh, hertz.
Yeah, we just can't hear it. It's
was
like
thinking
the higher ones would be
Why can't we hear it?
I get pretty deep.
we don't
That's like a
have
dog whistle.
our ears don't have the capacity for that kind of vibration to hear those things. Like our bones won't do it.
I thought it was saying decibels.
No,
I was
no.
like, that would destroy our eardrums.
Yeah, no, these are hertz. So
The
this is
jet
the
thing
sound
was like
wave
underneath.
wavelength. So yeah, anything above 20,000, that's like a dog whistle where the
Yeah.
dogs can hear it, but we can't. And that's just because we don't have the delicacy to pick up on those vibrations. And then anything below 20 hertz is not going to vibrate enough for us to hear it.
That would be like a low C on a tube.
Even lower, yeah. The vibration is so low that we're not going to hear it. So we're going to write and graph a compound inequality that describes the frequency of sounds you cannot hear. Okay? So what we cannot hear is we cannot hear anything below 20, right?
I want to test.
So
So this is an and one?
this is an or.
So the X is gonna be what we can't hear?
Yeah, the X is going to be what we
Oh,
can't
I
hear.
really want to test. I don't think that's really true.
It is true. You can't hear a dog whistle. But a dog sing.
But you can't hear dogs. I heard dogs.
No, you can't hear it. It doesn't make a sound to us.
Okay,
Wasn't a
guys.
real
That's
whistle.
it, guys. It's
But when I the one I heard.
It's okay.
It wasn't a good
For the
number.
purposes of this
Yeah.
problem, it doesn't really matter. We could make these numbers up. So we cannot hear below 20, or we cannot hear above 20,000. So here's our compound inequality. And now we're going to graph it. So what I need you to do is I need you to make a number line and put 20,000 little lines on it, okay?
Yes.
Right. No, just kidding. Well, let's do this. We'll put 0, and then we'll put 20, like right next to 0. And then we'll put 20,000. on the other end?
I think 20 would be a bit closer.
Yeah, it would.
Why are you gonna be so particular?
Open circles because they're less than and greater than. Okay, less than is this direction, so we'll shade over here. Greater than is this direction, so we'll shade over here. And this is our union. Now, if I had asked you to graph what we can here, what we can here would be an intersection, because we can hear everything in between these. That would be where the overlapping occurs. So if we wanted to graph that, we're going to put less than and equal to, and then we're graphing in between. So we can hear anything in this range. So that would be an intersection, what we can hear, and what we can't hear is a union. It's going to separate. Does that make sense?
Why do they call it a union? It's like on the opposite.
Okay. So a union because we're taking the whole of both graphs, right? We're taking everything below 20 and everything above 20,000, we're putting them together. But with the ands, it's only the overlap. So technically, if x is greater than 20, that's everything that way forever. And if x is less than 20,000, that's everything this way forever. But we're only taking the part that's on both together.
Yeah.
Whereas with the union, we take the whole thing of both. Anything that would overlap and then anything that doesn't overlap as well. Where'd my, with the and, we had a situation where we could have two inequalities with the word and in between them, or we could have them combined in one statement. With or, there's no way to combine them into one statement. There's always going to be two inequalities with an or in between them. So we're going to add 7 to both sides on this one. So you solve them separately. So I get negative 2m is less than or equal to 20. Divide by negative 2. Actually, let's write those in a different color so that it's really obvious what I'm doing. Because I divided by negative, I have to flip my inequality. So I get m is greater than or equal to negative 10.
When you subtract 7,
Yeah, you would. Thank you. Wow. I suck today. That would change this number and this number and those two. All right. And remind me to give you your extra credit. So I subtract 7 from both sides. 13 minus 7 is 6. 6 divided by negative 2 is negative 3. Everything else stayed the same. Okay. When I come to my next equation, I'm going to subtract 12. And then I get 5m is greater than 25. Divide by 5. And I get m is greater than 5. Now remember, there's still an or in there. So what we have greater than or equal, so that goes this way. Greater than also goes that way. but it's an or, so we don't just do the overlap. We're going to shade the whole thing. Because an or is a union, which means we shade both parts on the same graph. Having them go the same direction is usually pretty rare. More often than not, they'll go in opposite directions when it's a union. But sometimes it does happen that you go in both directions, so you just shade the whole thing, whichever direction it is that they're going. I'm going to subtract 1 from both sides. So A will be less than 3. Or I can add 5 to both sides. So I get A is greater than 22.
And these are going to be going different ways, right?
So I'll have a 3 and I'll have a 22. Open circles because they're both greater than or less than, not or equal to. Less than 3 is this way, so I'm shading over here. Greater than 22 is this way, so I'm shading over here. And I'm done. All right, absolute value review. If you recall, absolute value of a positive number is a positive number. The absolute value of a negative number is also a positive number. And if I say the absolute value of a variable equals that same positive number, that means x equals either one of these, right? And when we had absolute value equations, we had to split it. So we had to say that x minus 6 equals 10, and we also had to say that x minus 6 equals negative 10. And then we solved each of those individually. And we got 2 answers. Okay, familiar? We have to do something very similar to this with the absolute value inequalities, where we're going to have to split it into 2 separate inequalities and then solve them both separately. If you have an absolute value with a less than or less than or equal to, these end up being ands. But you don't need to know that necessarily, just it's nice as a backup. Okay, I have the absolute value of m plus 2 is less than 11. Now I have to split this. And I have to have m plus 2 less than 11. And then I also have to have a negative 11. Here's where you want to remember. If I change the sign, I have to flip the inequality. So on the one that I make negative, I flip the inequality symbol. Okay. So it's kind of like when you multiply and divide by a negative, but it's just when we turn that answer negative, we flip the inequality symbol. Okay, and then we solve each of these separately. M is going to be less than 9. And n is going to be greater than negative 13. Negative 13's here, 0's here, 9 is there. Roughly. open circle, open circle. N is less than 9, that graphs this direction. N is greater than negative 13, graphs that direction. They're pointing towards each other. So I have an overlap. And I'll shade in the center. Okay. Same thing with the less than or equal to. I'm going to take that n minus 8 and I'm going to set it less than or equal to 2. And then I'm going to do n minus 8 is greater than or equal to negative 2. Okay. We'll add 8 to both sides. So I get n is less than or equal to 10. I'll add 8 to both sides over here. So I'll get n is greater than or equal to 6. Okay. I'm less than or equal to 10, so I get a solid circle, and less than goes that direction. I'm greater than or equal to 6. Goes in that direction.
What goes that direction?
Yeah, greater than.
No. Oh, yeah, never mind. I got it.
And then we'll shade in between them. What we cannot have is the absolute value of anything is less than a negative number. Right? We can't, absolute value is not negative.
Mm-hmm.
So it certainly can't be less than a negative. So if this happens, you have no solution. Okay. Greater than, these are going to end up being ors. So less thans are ands, greater thans are ors. But you do it the same way. We're going to take that 3n plus 6 greater than or equal to 12, and then we're going to do 3n plus 6 less than or equal to negative 12. And we're going to solve each individual. So again, same thing. If I make the second quantity negative, I flip the inequality. So I'll subtract 6 from both sides, which will give me 3, and that's not blue. 3n is greater than or equal to 6. And I'll divide both sides by 3. And I'll get n is greater than or equal to 2. And then I'll come over here. And I'll do the same thing, but with a different answer. And then I will draw my number line. Negative 6 is over here, 2 is over here. I am greater than or equal to 2. That goes this direction. And I am less than or equal to negative 6, and that goes this direction. So we have 2k plus 1 greater than 7, and 2k plus 1 less than negative 7. So we had to flip that. Subtract the 1. And I get 2k is greater than 6. Divide by 2. And I get k is greater than 3. Subtract the 1. 2k is less than negative 8. Divide by 2. And k is less than negative 4. greater than 3 goes this direction, less than -4 goes that direction. So I'm shading apart from each other. Remember I told you that you cannot have less than negative? You can have greater than negative. Because absolute value is positive, and positive is greater than negative, so this is still true.
But you can't have -3, -2, -1.
Right. So I couldn't have,
But how does that make sense though? Because if it's greater than -4, you're still gonna have
It-
-3, 2, 1.
that doesn't, this right here, no solution. Because absolute value is not less than negative. But absolute value is greater than negative, so this is true. So I can solve. And you just ignore, you just solve it. So then what I'm going to do is I'll split it. And I have -2c minus 3 is greater than -4. And -2c minus 3 is less than -4. Sorry, +4. I still have to change the sign. Except this time I'm going to positive. Can I end up flipping because I'm dividing by a negative, so c is less than 1/2. And greater than -7/2. But we're talking greater than. Less than is an and. Greater than is an or. So what happens when I graph this, I'm greater than -7/2. I'm less than 1/2, but it's an or. So I shade everything going this way and everything going this way, and my solution is all real numbers. And here's why that works. It does not matter what I plug in here. No matter what number this puts out, the absolute value of it is positive, correct? So no matter what number C is, it will always be greater than -4. Because it will always be positive.
Can you even do anything with the one on the right?
This, no. If you have a less than a negative, that's false, right? There's no solution because this is positive, and positive is never less than a negative.
So it's just wrong.
It's just no solution. But this is true. Positive is always greater than a negative, so it's going to be all real numbers. You don't actually have to do this.
All right.
If you have a situation like this where you have absolute value greater than a negative number, it's going to be true no matter what, so it's all real numbers. If you have absolute value is less than a negative number, that's never true, so it's no solution.
So why are we showing them?
Because it's a union. I was just showing you how it works.
Oh, I see. Okay.
Yeah, so they overlap, but they continue to go in the opposite direction. But really what happens is when you see this, I'm just going to put anything, just any this, where it's greater than a negative. It doesn't matter what's going on over here. All real numbers. Because no matter what's in here, this will always be true because absolute value is always positive. Do you see that? And likewise, absolute value is always positive, so it doesn't matter what's going on in here, it'll always come out positive, which means that it cannot be less than a negative. So this will always be no solution.